Hi there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you, yes, you, Algebra 1. And in this lesson, we're going to look at piecewise functions. And it says, so far, all of the functions you have encountered have been written as a single equation. However, in algebra and in life, there are scenarios that require two or more equations to accurately represent the scenario. So if we're taking a look at exercise number 1, it says Lorelei works as a gemologist. She gets paid based on the weight of diamonds she sells. If Lorelei sells less than 5 carats, she is paid $200 per carat. If Lorelei sells 5 or more carats, she is paid a $1,000 stipend plus $200 per carat. Since Lorelei's income varies based on the number of carats she sells, you would need to use two equations to represent this situation. The piecewise function below represents all of Lorelei's income possibilities. So this right here represents a piecewise function. We have y equals, and then it splits off into two different functions. The first function is 200x, while the second one is 200x plus 1,000, to represent those two scenarios above. Now it says it has a comma next to each function, and it gives an interval over where these functions occur. So remember, she made $200 per carat if she sold less than 5 carats. So that means the number of carats would have to be between 0 and 5, but less than 5. If she sold equal to 0 carats, yeah, we would use this function. She'd just make $0. And then we look at this function. It says 200x plus 1,000, and that was if she sold 5 or more carats, and that's why it says x is greater than or equal to 5. Any number of carats that's greater than or equal to 5 would go in this function. So depending on how much she sells determines which function to use to see how much she gets paid. So the first thing we want to do is we want to graph the piecewise function on the graph below. And to do this, graph the equation y equals 200x over the domain interval 0 to 5, not including 5, and then graph the equation y equals 200x plus 1,000 over the domain interval x is greater than or equal to 5. So I might do this a little bit differently, and that's because I have the capability to erase easily. So here's how I'm going to go about doing this. And what I'm going to do is I'm going to do what it says. I'm going to graph the equation y equals 200x from 0 to 5. Notice my inequalities. I'm going to have a closed circle at 0 and an open circle at 5. So again, the equation is 200x starting at 0. So that's a y-intercept of 0. And then our slope is 200 over 1. So I'm going to go up 200. Pay attention to the scale. It's going up by 200s. So I'm going to go up 200 over 1, up 200 over 1, up 200 over 1, up 200 over 1. And when I go to this final spot, this is where 5 carats is. And remember, we're putting an open circle on 5 carats because it's just less than 5. It goes all the way up to 5, but it's less than. And then we're going to connect that with a nice straight line to represent 200x over that interval. Now, what I said before was I'm going to do it a little bit different way, because when I graph the equation y equals 200x plus 1,000 over the interval of x is greater than 5, x is greater than or equal to 5, I don't know exactly where that point's going to occur. So I'm going to start like normal with a y-intercept of 1,000. And the slope is going to be 200 over 1. So I'm going to start at 1,000 and go up 200 over 1, up 200 over 1, up 200 over 1, up 200 over 1, up 200 over 1. Okay, so here's my actual starting point, because this is where x is equal to 5. And remember, we're graphing this over the interval where x is greater than or equal to 5. So we actually don't want any of these points before it. So I'm going to erase those. So my function is going to start there. And then I'm going to continue my up 200 over 1, up 200 over 1, up 200 over 1 for all of the points that fit on my coordinate plane right there. And again, I'm going to connect these points with a nice straight line. And I'm going to put an arrow on the end of that to show that that end goes on forever. So what we have here is we have a piecewise function that shows how much Lorelei will make for any number of carats. If she sells less than 5 carats in diamonds, then we use this piece of the function down here. But if she makes 5 or more, if she sells 5 or more carats in diamonds, then we're going to use this function up here. So let's take a look at the questions that are asked afterwards. How much would Lorelei make if she sold 20 carats worth of diamonds? So we look at the graph, we go to 20 on the carats, and we realize we don't have 20. So we have to do this way algebraically. So we look at our intervals, and we know that there's going to be 20 carats. So is 20 a number between 0 and 5? And the answer is obviously no. 20 is not a number between 0 and 5. Is 20 greater than or equal to 5? The answer is yes. So we're going to use this function to determine how much she'll make when she sells 20 carats in diamonds. So we're going to use y equals 200 times 20 plus 1,000. And we're going to do some math right here. Y equals, that's going to be 4,000 plus 1,000. And that means she's going to make $5,000 for selling 20 carats worth of diamonds. All right, how many carats did Lorelei sell if her income was $2,800? So again, we look for 2,800 on this graph. Oh, we do see 2,800, it's right here. And we follow that to where we hit the graph. And we hit the graph right here, and we follow that down to see how many carats she would have sold. And that's going to be 9 carats. 9 carats. And again, if we wanted to do that algebraically, we could set, well, $2,800. We would see that you only make up to 1,000 selling in the first range. So we're just going to set the second equation equal to 2,800. So we could do 200x plus 1,000 is equal to 2,800. Subtract 1,000, subtract 1,000. And we'll be left with 200x equals 1,800. And when we divide both sides by 200, we'll be left with 1,800 divided by 200, which is 9. So you'd get 9 carats that way as well. But when you have the graph, use the graph, because all we're doing is just following the graph along to see where it intersects, and then following it down to see what the x value is, which is 9. A little bit easier than algebraically. So 9 carats is our answer there. So we have now looked at our first piecewise function, and if this video is helpful in graphing a piecewise function and answering the questions that follow, please give this video a thumbs up, and you're now ready for exercise number 2 with piecewise functions. Thank you for watching.